convert this RGB image to grayscale, I have a function here, RGB to gray. Okay, so if I have image here I1, I'm just seeing it in the commented line. So if I have a function called I1 case sensitive, MATLAB it, so I1 is equal to, if I say RGB to gray, okay, RGB to gray of I. Okay, I is my original image. I'll convert the color image to grayscale, and I'll show of I1, because I'm not used to two figure window. So the original figure window wherein I'll have the original image will be again overwritten by I1. So I'll not get I here. The color image won't be seen after I execute it. I'll get only the grayscale image. Okay. Having the image here. Yeah, this is the image. Okay. So the original image, color image is just converted to grayscale. Okay. So if you go through the workspace, monitoring workspace is very, very important. They've used all these variables, and all these variables are demonstrated here. Imagine here, like I is the color image, okay, which is of 135 rows and 198 columns and 3 planes. Okay, that means it's a color image. Okay, whereas I1, I just converted the original image I, the color image, into a grayscale image, which is of size 135 cross 198, unsigned 8-bit integer type, which is a grayscale. Okay, so this into 3 will be there only for color images. Okay, so this is how the image, the color component can be done. And if you want actually the color component to be reframed, you know, you could even do that. I've got another code for color component. Okay, so let us execute this code. This is the original image wherein I'm converting the, I'm extracting the red component, green component and the blue component of the image. How am I doing it with the code? I'm just taking the original image, stored in again, complete image stored in R, complete image stored in G, complete image stored in B. Okay, then I'm just making this R plane, means it's actually in your plane number, plane index number 1. Okay, I just make sure the plane 2 and plane 3 is 0. So what is left out? Only the red plane is left out. So from the whole image, if I make the plane 2 and 3 to be 0, that means the plane which is left out is actually the red component. Okay. Similarly, to extract the green component, you know, green component's plane index is 2. So I'll make sure the red component plane, or the red plane which is indexed in 1, and the blue plane which is indexed in 3, I make it to 0, and I can extract the green component. Okay. If I want to have the blue component to be extracted, I'll make sure the red plane as well as the green plane is completely 0, and I'll get the blue component. Okay. So after I've got here, if I'm extracting the red, green and blue component, which is there in this RGB, if I mix up together, if I'm summing up all these values, I'll get the reconstructed image, which will be exactly the same as that of your original image. Okay, because I've not done anything with the alteration of the component. Okay, if you want, for example, this it's this yellow colored component, okay, this pepper, okay, to be even more colored, okay, or more color to be varied, okay, I can adjust the corresponding plane values, okay, and I can make it to be enhanced. Okay, that's what is happening in your color pop when you are using some filters, and this is what is happening in the color pop, right?